All right, so we're going to deal with something pretty cool today. We're going to take a look at the matrix and how we can uh, use the matrix in representing reflections. We talked about the matrix a little bit last time with adding and subtracting when we were talking about translations. We also use matrices when we are working with reflections. So first we need to talk about how we multiply matrices. It's a little bit more involved than adding and subtracting. And with adding and subtracting, we just added or subtracted whichever value was in the specific quadrant of the matrix. When we multiply, it's a little bit more involved. So take a look at the first step. So if we're looking at the matrix, we take the first horizontal row and multiply it by the first column. And we can see that in color-coded here in the solution example. So we just multiply the first result in the first row, first column, times the first one over here. So 1 times 2. And then we move over 0 times and move down -1. And then we move over to the next column. So keeping the first row, 1 times -3 and 0 times 8. And that puts us in the next row and column. And then we're going to go down to the bottom row. Multiply the bottom row, 4 times 2 and 5 times -1. So we just work our way through. We just multiply everything in the row times everything in the column. Once we've done that, we move over to the next column. Stay in the bottom row, 4 and 5 in the final column. So 4 times -3 and 5 times 8. Once we've multiplied those together, now we can simplify. So 2 plus 0 is 2. -3 plus 0 is -3. 8 plus -5 is 3. And -12 plus 40 is 28. So when we multiply the 2 by 2 matrix, we end up with another 2 by 2 matrix. Okay, if you need to take more time to review that, look that over a little bit. We're going to apply that now to the reflection matrix. So keep in mind, remember, with the reflection across the x-axis, only the y-coordinates are changing. The x-coordinates stay the same. So in this matrix, remember the x-coordinates are represented in the top row. So we're keeping the x-coordinate, that's why we're multiplying by 1. And this 0 here gets multiplied because we don't need to add on anything with our y-coordinates. And then with our y-coordinates, we don't need to add anything on with our x, but we're flipping, making the y-coordinate the opposite. And then the same idea when we're reflecting the y-axis. The x-coordinate becomes the opposite. That's why we're multiplying by -1. The y-coordinate stays the same. That's why we're multiplying by 1. So if we take our pre-image of the triangle DEF, and if we want to reflect it across the y-axis, we need to use the reflection matrix for the y-axis. And now we're multiplying by the polygon matrix, which is 1, 2, 3, 3, and 4, 0 are the 3 coordinates of the triangle. That's the x-coordinates on top, y in the bottom. Now we just multiply. So we start with the first row, multiply by the first column. So -1 times 1. 0 times 2, and we add that up. That goes in the upper left. And then we move to the next column, -1 times 3, and 0 times 3. And we add those together, then we go to the final column, -1 times 4, and 0 times 0. Then once we've multiplied the first row times all 3 columns, next we go to the second row, multiply by all 3 columns. So 0 times 1, and 1 times 2. 0 times 3, and 1 times 3. 0 times 4, and 1 times 0. Then we simplify those. That gives us our image matrix. Notice it gives us now coordinates, -1, 2 for D, -3, 3 for E, -4, 0 for F prime. So that's the way that we can combine all of our calculations into one simplified problem all in one spot. Okay, so why don't you do some practice with that, and we'll see you next time.